children, I am Ekta. Imagine looking at a circle and noticing that all four corners of a shape, called a quadrilateral, are sitting perfectly on the circle's edge. This special kind of quadrilateral is known as a cyclic quadrilateral. Today we will explore the fascinating properties of these quadrilaterals and uncover their secrets. We will learn how their opposite angles add up to 180 degrees and how this property helps us solve challenging problems. Get ready to discover the hidden connection between shapes and unveil the mysteries of cyclic quadrilaterals. Welcome to an exciting lesson on cyclic quadrilaterals. Picture a quadrilateral with its four vertices resting on the edge of a circle. Today, we will unlock the special properties of these quadrilaterals. We will see that the opposite angles of a cyclic quadrilateral add up to 180 degrees. This property will become our secret weapon as we solve captivating problems. By the end of this lesson, you will have the power to unravel the mysteries of cyclic quadrilaterals and use them to conquer geometry challenges. Learning outcomes. At the end of this lesson, you will be able to understand the concept of cyclic quadrilaterals and their special properties. Identify that opposite angles of a cyclic quadrilateral are supplementary. Apply the properties of cyclic quadrilaterals to solve geometric problems and find angle measurements. Determine the equality between exterior angles and interior opposite angles in a cyclic quadrilateral. Keywords: cyclic quadrilaterals, opposite angles, supplementary, exterior angle, interior opposite angles, converts, angle measurements, circle geometry. Now, let us see a special quadrilateral with its properties called cyclic quadrilateral. A quadrilateral is called a cyclic quadrilateral if all its four vertices lie on the circumference of the circle. Now we are going to learn the special property of cyclic quadrilateral. Consider the quadrilateral ABCD whose vertices lie on a circle. We want to show that its opposite angles are supplementary. Connect the center O of the circle with each vertex. You now see four radii OA, OB, OC and OD, giving rise to four isosceles triangles: OAB, OBC, OCD and ODA. The sum of the angles around the center of the circle is 360 degree. The angle sum of each isosceles triangle is 180 degree. Thus, we get from the figure 2 into angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle at center O is equal to 4 into 180 degree. Two into angle 1 plus angle 2 plus angle 3 plus angle 4 plus 360 degree is equal to 720 degree. Simplifying this, angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 180 degree. You now interpret this as angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 180 degree. Sum of opposite angles B and D. Angle 1 plus angle 4 plus angle 2 plus angle 3 is equal to 180 degree. Sum of opposite angles A and C. Theorem: opposite angles of a cyclic quadrilateral are supplementary. Let us see the converse of the above theorem, which is very useful in solving problems. Converse of theorem: if a pair of opposite angles of a quadrilateral are supplementary, then the quadrilateral is cyclic. Example: if PQRS is a cyclic quadrilateral in which angle PSR is equal to 70 degrees and angle QPR is equal to 40 degrees, then find angle PRQ. Solution: PQRS is a cyclic quadrilateral given angle PSR is equal to 70 degrees. Angle PSR plus angle PQR is equal to 180 degrees. We know sum of opposite angles are 180 degree. We already know PSR value and substitute PSR value in the given equation. We get 70 degrees plus angle PQR is equal to 180 degree. Number term take into right side, we get angle PQR is equal to 180 degrees minus 70 degrees. Therefore, we get angle PQR is equal to 110 degrees. In triangle PQR, we have angle PQR plus angle PRQ plus angle QPR is equal to 180 degrees. Already we know PQR and QPR values and substitute PQR and QPR values in the given equation. We get 110 degrees plus angle PRQ plus 40 degrees is equal to 180 degrees. Add number term and take into right side, we get minus 150. So we get angle PRQ is equal to 180 degrees minus 150 degrees. Finally, we get angle PRQ is equal to 30 degrees. Exterior angle of a cyclic quadrilateral. An exterior angle of a quadrilateral is an angle in its exterior formed by one of its sides and the extension of an adjacent side. Let the side AB of the cyclic quadrilateral ABCD be extended to E. Here, angle ABC and angle CBE are linear pair. Their sum is 180 degrees and the angles angle ABC and angle ADC are the opposite angles of a cyclic quadrilateral and their sum is also 180 degrees. From this, angle ABC plus CBE is equal to angle ABC plus angle ADC, and finally we get angle CBE is equal to angle ADC. Let us see one theorem. If one side of a cyclic quadrilateral is produced, then the exterior angle is equal to the interior opposite angle. Example, in the figure given, find the value of x degrees and y degrees. Solution. By the exterior angle property of a cyclic quadrilateral, we get y degrees is equal to 100 degrees and substitute we get x degrees plus 30 degrees is equal to 60 degrees. Number term take into right side, we get x degrees is equal to 30 degrees. Example, find the value of x in the given figure. Solution. In the cyclic quadrilateral ABCD, angle ABC is equal to 180 degrees minus 120 degrees is equal to 60 degrees. We know that angle BCA is equal to 90 degrees. Therefore, substitute all the values, we get x is equal to angle BAC is equal to 180 degrees minus 90 degrees plus 60 degrees. Therefore, x is equal to 30 degrees. Example, in the given figure, AC is the diameter of the circle with center O. If angle ADE is equal to 30 degrees, angle DAC is equal to 35 degrees and angle CAB is equal to 40 degrees. Find angle ACD, angle ACB, angle DAE. Solution. Here sum of angle is 180 degrees and we know DAC value is 35 degrees and ADC is 90. Substitute values, so we get angle ACD is equal to 180 degrees minus 90 degrees plus 35 degrees is equal to 180 degrees minus 125 degrees is equal to 55 degrees. finally we get angle ACD is equal to 55 degrees. In the second question, sum of angle is 180 degrees and we know BAC value is 40 degrees and ABC is 90. Substitute values, so we get angle ACB is equal to 180 degrees minus 90 degrees plus 40 degrees is equal to 180 degrees minus 130 degrees is equal to 50 degrees. Angle DAE is equal to what? Here angle ADC is equal to 90 degrees. Here angle CAE is equal to 180 degrees minus 120 degrees, that is equal to 60 degrees. Already we know CAD is 35 degrees. Substitute the value, we get angle DAE is equal to 60 degrees minus 35 degrees is equal to 25 degrees. Example, in the given image, center O, find angle OAC. Reflex, angle AOC is equal to 2 into angle ABC. We get is equal to 2 into 120 degrees is equal to 240 degrees. Therefore, angle AOC is equal to 360 degrees minus 240 degrees is equal to 120 degrees. Hence, angle OAC plus angle OCA is equal to 180 degrees minus 120 degrees is equal to 60 degrees. From that, we get 2 angle AOC is equal to 60 degrees. From we get, therefore, OAC is 30 degree. Points to remember. A cyclic quadrilateral is a quadrilateral whose 4 vertices lie on the circumference of a circle. The opposite angles of a cyclic quadrilateral are supplementary, meaning their sum is 180 degrees. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. The properties of cyclic quadrilaterals can be used to solve problems involving angle measurement and circle geometry. Thanks for watching. Like, share, subscribe.